Okay, so lovely to be here. Thanks for the invitation. And obviously we're changing from cancer immunotherapy, which is something I used to work on about 10 years ago. It's great to see some progress in that field, to infectious diseases. So I'm going to only speak for about 25 minutes, so we might get to lunch very, very quickly if Katie doesn't turn up, though I could probably give part of her talk as well on vaccines. So, I'm going to talk about the immune response in survivors, and the reason we're doing this work is to learn about the parameters, requirements of an effective vaccine as well. So, and that's why Katie's talk would have fitted, hopefully will fit well afterwards. Okay. So, just in case you don't know the basics of Ebola, so it's a filament-shaped virion particle, and it's decorated in these glycoproteins, and that's the basis of all the vaccines that are out there, and that's the basis of the immune monitoring and analysis that I'm going to be describing today. This horrible picture is just to remind us that the only reason that we have these vaccines ready to trial back when the outbreak started, or didn't get into clinical in about 2015, was because of Project BioShield, which was initiated by the US government after 9/11. The rest of the world pretty underprepared, but the US government put in many hundreds of millions of dollars into research into emerging diseases that could theoretically be turned into biological weapons, and Ebola was top of that list because of some data that was uncovered after the Cold War, where the Russians had weaponized Ebola and made it able to spray it as an aerosol. So a lot of money went into it, and therefore we were pretty well prepared. So the work that we became very much involved with and led a lot of it is all derived from our association with the European Mobile Laboratory. So back in 2013, the European Union funded about 5 of us who run big, what we call containment level 4 laboratories in Europe. Porton Down obviously has those facilities. The groups in Germany, Italy, Sweden and France also have those facilities. And we worked with the German military, and they were able to train us on how to do diagnostics in resource-limited settings, basically in a tent, and handle high containment pathogens with mobile containment facilities. Obviously, all the diagnostics and PCR we do anyway in our labs because we're associated, some of us, with clinical services to our governments. So, this is just to show that when the virus samples finally reached Europe to be diagnosed from Gueckedou, the epicenter of the outbreak, which is in Guinea, they came in around mid-March, and by March 23rd, the diagnostics which were performed at the Brown Institute in Germany and also in Lyon P4 lab showed it was Ebola Zaire, and within 7 days, the European Mobile Laboratory was actually in a tent doing PCR diagnosis for Ebola, and that's the first treatment centre that MSF established in West Africa. So if you are prepared, and the European Union was fantastic in giving us the money, you can make things happen very rapidly. And so all this abuse of the World Health Organization not responding quick enough is not entirely accurate. There were many other parameters of the pathogen and the location of the outbreak that led to its the large size of number of infected individuals. So we were able to get, so the blood samples come through here, dipped in chlorine through a little, this is a CL4 facility, inactivated, RNA prepped, and then onto PCR. So this RNA prep we're able to ship back to Europe and do some interesting work on. And what we did is to look at the mutation rate of the virus over the first 10 months. We were lucky because we had good relationships with the West African government and could get the samples out, collaborated with a number of other colleagues across Europe, and basically could show that the glycoprotein that everybody's targeting and for their vaccines was changing a bit because a big fear was there'd be immune escape and the vaccines that the Americans had spent hundreds of millions of dollars on would be useless. But fortuitously, most of those immuno acid changes that did occur were relatively short-lived. Some of them were adopted and taken on further as the disease progressed, especially this A to V in position 82. But we now know that this is not an issue for the efficacy of the vaccines that have been trialled in Guinea, at least. And the mutation rate wasn't as high as flu, as first theorized. It was what people anticipated it would be, which is extremely helpful, about 2 changes per month through, and that's in a blood cycle rather than semen or breast milk or in the CNS. And this data also helps you to track the virus through molecular epidemiology. This is a beast analysis, and we worked with Andrew Rambo at Edinburgh University to do this work. And it allows you to look at the phylogenetics of the virus over time, and also we had all the location data as well. And we can see the virus spreading over from Guinea over into Sierra Leone, and then back from Sierra Leone into Guinea, and then back into the cities, and huge numbers of infected individuals resulted. So we also were able to use that same Illumina RNA-seq data to look at the host response to infection. And we managed to identify a group of 10 genes that were upregulated that were extremely good predictor of lethal outcome of death. And this was recently published. But it shows the involvement of the innate response in dictating if you're going to live or die after being exposed to the pathogen. Also working with Cesar Moraz-Fontella, this is another member of the European Mobile Lab who set up a mini CL4 lab near another treatment centre near the capital in Conakry. So fresh blood samples were coming in, and using the Guava mobile flow analysis, he showed that during the acute phase, if you have a very high expression of CTLA-4, it is associated with death, a lethal outcome as well. So it gives us an idea that maybe we can look at different treatment regimens in trying to recorrect that CTLA-4 activity, and hopefully people have a better chance of survival. So my main interest was to study the immune response of survivors. This was many weeks or months after they recovered, so they would not be infected in their blood with Ebola. Still may be in their body, but not at least in their blood. So most of this work was done at Cat2, or Class 2 HUS, but obviously we checked all our samples to make sure they were negative by PCR and weren't raging with virus there. So dogma suggests then that if you've been infected with Ebola or many other diseases, it's true as well, that naturally acquired immunity is going to protect you from exposure at some later point. Therefore, looking at natural acquired immunity is a good way to find a picture of an effective response that a vaccine needs to imitate. There has been some work in the past on looking at antibody responses in survivors, and I'll mention that, but it is limited. T-cell responses, not a lot is known for survivors. And there's talk about a certain T-cell phenotype after receiving vaccines based on the adeno vector system expressing Ebola glycoprotein. A lot of this work was done in non-human primates, and there was some papers by Nancy Sullivan's group at NIH saying that a particular phenotype is associated with protection. So we also want to look at that in the survivors as well. So another interesting point we want to delve into a bit more detail is that some people that get exposed to the virus get infected, but they don't have significant symptoms and no one knows they're infected. So this was reported in an outbreak about 20 years ago, and using more later techniques and technologies, we want to try to look at the effect of infection in people that are subsymptomatic or asymptomatic as well. And what does that immune response look like? So great work done by colleagues in CDC Atlanta in an earlier outbreak, and they did some initial work looking at the longevity of the antibody response, and you can see that it can go for anything up to a year or so, but these numbers end very, very low, so maybe not so significant. This is only done by ELISA as well. We want to look at the function of that immune response, look at neutralizing activity as well. But some really good work had been done. So we set up 2 cohorts of communities that had survived major outbreaks from the 2014-2016 outbreak. One in the epicenter of the outbreak, which is a place called Gueckedou, which borders Sierra Leone, very close, and Liberia. Hence, one of the reasons the outbreak spread so rapidly to the region. Another one is a couple of hours north of Conakry in a prefecture called Koya. Again, a big outbreak occurred there. In both locations, the European Mobile Lab did all the diagnostics for those treatment centres. So good links with the local population and some good trust there. So working with the survivors leaders groups, we persuaded the individuals, the survivors, to give a blood donation, which might sound easy for you guys, but it is a little bit difficult out in the field, especially when trust isn't always highest on people's minds. But luckily we had that relationship and were able to get that through. And we also took blood samples from these very special people, because these are the people that nurse their sick or dying relatives, and were exposed to lots of body fluids where we know the virus is heavily laden with, but they didn't get sick. We wanted to see, do they actually have an immune response, and if so, how did they get it, and why didn't they show symptoms? There's something unique about that immune response. So, in summary, about 120 survivors, 60 or 70 or so contacts, the people that cared for the sick individuals, and some people, 9 people who did not knowingly know they were exposed at the time. But when you're in Gueckedou or Koya during the outbreak, you wouldn't know really for sure if you were exposed or not, because we now know that you don't have to be symptomatic to be able to shed virus and infect others. So we did a lot of work out in the field because it was near on impossible to get viable PBMCs back to the UK, though subsequently we have had some success there. So we did ELISpot in the field, overlapping a peptide library that Katie at UA actually helped us with and supplied some of that material. So hopefully she's going to give you a bit more detail about that in her vaccine studies. And plasma was shipped back to Europe, given to our colleagues at Marburg University, where they've got a fantastic CL4 facility and are world experts on neutralization assays with Ebola Zaire. We did ELISA and then subsequently Western blot to try to work out what part of the virus the immune system is seeing. So like I said, we worked with Guinean nationals. These 2 gentlemen worked from the European Mobile Lab for 2 years, and as part of our capacity building approach, funding, I could say, from the EU and subsequently from the US government, and now they're both doing PhDs associated with one with my lab and one with Stefan Gunther's lab in the Bernard Nock Institute in Hamburg. But those PhDs are located in Guinea. And this is a very able individual that works in our group, Iba Hall, who went out on many occasions with us to set up the lab and do the ELISpot on site and all the blood processing. So this is the first ELISpot data we got back. And this is, like I said, the overlapping peptide library. Use two megapools, 1 and 2, and then there's the subdivisions of the different subpools to further define which part of the protein the individual is making most of their T-cell response to. So this is a value of 150 per million. This is Sasabas, the leader of the survivors group that I showed you, and this is my T-cell response. So I got both the chimp adeno vaccine, part of the Genomes trial, and then I got a booster when I was out in Guinea we were trying to do a promotion to get people vaccinated, and that was with the VSV vaccine that later proved to show efficacy in a phase 3 trial in West Africa. So this was 2 weeks after my VSV boost, and still this survivor, that's a year after survival, has got a T-cell response that's stronger than mine. This is my T-cell response 4 weeks after the booster. So you can see obviously that effector cell numbers are rapidly dying off, and there's my remaining response. So probably about 10-fold higher response than me, and that's a year after survival. And we get differences, as you imagine, with different HLA, with different subpools that he sees and I see. And I've seen the antigen in response in the context of VSV and chimp adeno, and he's seen it obviously with a proper infection, authentic infection with Ebola Zaire. It might also be due to the fact that the virus is able to survive in these immune-privileged sites. We know that it can last for over a year, if not 2 years, in semen. It can hide in the CNS, it can linger in breast milk. So is there a possibility that the antigen is seeping back into the bloodstream and re-stimulating both the T-cell and antibody response? So that's leading us to do some additional work, and we managed to get some T cells out of Guinea with a lot of effort, and now we're starting the process of trying to phenotype that T cell response. To see, is it central memory, is it effector memory? Can we get an idea from those markers when it last was exposed to antigen? And also the T-cell CD8 response, does it parallel what they saw in non-human primates that correlated with what they thought was protective immunity? So this, Tom Tipton, who's in the audience, has done some initial work to show that we can resuscitate these cells after the abuse that they've taken out in the field and on the way from West Africa back to our labs. It looks like they are behaving relatively normally. Well, he's using me as the normal, so I don't know if I behave normally, which is, it's looking positive, and some initial analysis just to make sure that these survivors can still see, this is after peptide exposure to megapool-1 from the Ebola glycoprotein, I can still see and recognize the antigen. This is me about a year and a half after vaccination, and there's not much there to see. So, in summary then, the survivors have a robust antibody and T-cell response that lasts for at least a year. Some more data shows that we've got a 5-year program that even after 2 years, those T-cell responses and antibodies levels are not waning. That some survivors don't seem to have an antibody or T-cell response, and that's not just our work. Other people I've heard who are doing studies in Liberia also have identified a number of survivors that don't appear to have an antibody response, at least, because I haven't looked at T-cell. The immune response doesn't wane after that, in that 14-month period, and what is the reason for that? Is there re-exposure? And hopefully we hope to find to determine the difference between the memory response and effective response. And a good number of people in West Africa were infected and are recorded as such because they were never PCR tested and never presented with symptoms. And what impact does that have on vaccination? But basically, you'll be trying to vaccinate a population with a live recombinant vector system that they already have immunity, so that may have a detrimental effect. It may also have a positive effect. And hopefully, we'll be able to give some idea on that effect on a study that we're currently doing with the World Health Organization. And the most important slide is the people that worked on this programme, a massive international collaboration, fantastically supported by the European Union, and the key work that enabled it all to happen is Stefan Gunther, who's the director of the European Mobile Lab, and obviously the work of the people in my team, and Tom, Anipa, and Ruth, who did a lot of the immunology work that I showed you, and our collaborator in Marburg, who did all the work on neutralising antibody. And obviously recognise the funding from the European Union and the Food and Drug Administration. And I'll just leave it there. Thank you.